This is problem number 5 from section 9.4. In this problem, they want us to solve the system if possible. We've got two different ways we can solve it. We can use, because we're working with matrices, I guess this is a system, so we could do graphing, elimination, or substitution, but we're strictly working with matrices right now in this section. So we're going to either use Gaussian elimination or Gauss-Jordan elimination. Now in this case, I think Gaussian elimination is usually, it can be a little quicker, a little less writing when you're writing out every step. So let's go ahead and use Gaussian elimination here. Now you would say with backwards substitution, but we know we're going to do backwards substitution anyway. So this is going to be -1, 1, 1, -2. This is -1, 4, -5, -20. And this is 6, -4, -10, 0. I'm going to start off by canceling the bottom row. And I'm going to cancel the bottom row using, I'm not going to cancel the bottom row, bottom left-hand corner. And I'm going to do that using, I think I'll use that top row there. So I'm going to multiply the top row by 6. So 6R1. That's going to give you -6, 6, 6, -2. Nope. Multiplied -2 by 6, so that's -12. -12. And then the middle row is still -1, 4, -5, -20. Bottom row is 6, -4, -10, 0. We're going to take row 1 plus row 3. That's going to equal row 3. As we do that, we're going to get 0 on the bottom left. This is going to be 2. 6 and -10 is -4. And -12 and 0 is -12. And then we're going to take and rewrite those. So this is -1, 4, -5, and -20. And we get -6, 6, 6, -12. Now I'm going to cancel this middle row right here. So in order to do that, I'm just going to take the top row and move it back to what it was originally. Well, sort of. It was -1 originally. I'm going to take this times -1/6 on the top, row 1. And when you do that, you end up with 1, -1, -1, 2. And we end up with -1, 4, -5, -20, 0, 2, -4, -12. Now we're going to take row 1, add it to row 2. That's going to equal row 2. So when we do that, we're going to get 1, -1, -1, 2. This will be 0, 3, -6, -18, and we end up with 0, 2, -4, -12 on the bottom. All right, just rewriting it. Okay. We need to cancel this bottom left, or no, sorry, the middle, bottom left, the bottom middle, 2 to be 0. So we're going to multiply the top by 2. So 2R2. It's going to give you 2, -2, -2, 4. And then we're going to get 0, 3, -6, -18 still in the middle. Bottom is still 0, 2, -4, -12. Now we're going to take R1 plus R3. That's going to equal R3. Oh, made a mistake. So the mistake I made there is I can't use the top row to cancel the bottom row, because if I do that, I'm going to bring that 2 down here. Hopefully you can see that, right? That 2 plus 0 right away, I'm going to have 2 down here. So that doesn't make any sense. So actually, we haven't screwed anything up yet. We're just going to not do that piece. And instead, because I didn't really need to take that times 2, I'm going to take the middle row, and we're going to multiply the middle row. They're all divisible by 3. So I'm going to multiply the middle row by 1/3 and the bottom row by -1/2. And I'm actually going to multiply the top row by 1/2. So I'm going to go 1/2 R1. I'm going to go 1/3 R2. And I'm going to go -1/2 R3. That's just going to lower all these numbers down. So as I do that, I get 1, -1, -1, 2. The middle, I get 0. This will be 1, -2, -3. The bottom will be 0, -1, 2, 6. That'll work better. Now we're going to take our, let's see, let's take our, let's see, we did 1/3 here, didn't we? Oh, I screwed that up. That shouldn't be -3. That should be -6, right? 1/3 times this -18, that's -6. My bad. That's a 6. So we're going to take R2 plus R3. That's going to equal R3. As we do that, we end up with, on the bottom, 0. 1 and -1 is 0. -2 and 2 is 0. And -6 and 6 is 0. So as you can see, it's easy to make silly mistakes. So it's really important to make sure you're not careless. Now you should see we got a little issue here. We got all zeros on the bottom. So what's that really telling you? Well, this is telling you with matrices that we have this whole 0 equals 0 for one of our equations. What does 0 equals 0 mean when we end up with that? That means we're going to have an infinite solution problem here. So what do we do when we have an infinite solution problem and we have matrices? Well, when we have an infinite solution problem with systems of equations where we're doing elimination, substitution, and stuff like that, we pick a variable. So I'm going to just kind of mark this up here. We pick a variable such as z to be our infinite solution variable. And then we write y in terms of z, and we write x in terms of z. So we want to write these two equations out, and we want to basically rearrange them so we end up with x in terms of z, and x in terms of z, and y in terms of z. So let's write this first equation out. That first equation would be y minus 2z equals -6. I want this y in terms of z, so I'm going to add the 2z over. And I get y equals 2z minus 6. So this is going to be 2z minus 6. Y in terms of z, right? So 2z minus 6 is what y would be. Now I'm going to take this last little piece here, and technically I need an equation with x in terms of z, right? So I need x in terms of z. So I can get that by taking this middle row and adding it with the top row. So I'm going to take R2 plus R1 equal R1. And when I do that, I end up with 1, 0, -3, -4. Still 0, 1, -2, -6, and 0, 0, 0, and 0. So we're going to now take this top row and write it as x minus 3z equals -4. And this is now going to be x in terms of z. We're going to add the 3z over, and we're going to say x equals 3z minus 4. So we're going to have 3z minus 4 for our x value there. So our solution is infinite solutions, but z is the infinite variable, 2z minus 6 is the expression representing y, and 3z minus 4 is the expression representing x. And we could see that we got there with all zeros on the bottom, meaning 0 equals 0 is infinite solution.